Okay, let's go ahead and take a look at.
This is Chapter 4, Topic 12, Day 2. So this is more problems completing the square, using the completing the square to solve these. And these are going to be problems that have an a value. So completing the square cannot be done unless the a value is 1. So it was a very simple trick to take care of an a value that's not 1. So in this case, the a value is 3. Divide everything by the a value. Literally everything. This, all get divided by the a value. And we get x squared minus 2x plus 3 equals 0. Now this is okay because this is the division property of equality. What I'm really doing here is dividing the left side by 3 and the right side by 3. And then I'm distributing the division to each of these. So I'm getting x squared minus 2x plus 3 equals 0. Alright, well now I've got something that I can actually work with to complete the square. Because I can put the 3 on the other side. Let me get rid of this for a minute so I can use this. And I'm going to have x squared minus 2x. And then on the other side I'm going to have negative 3. Now I can complete the square. So I need to find the number here that will make this into a perfect square. So half of negative 2 is negative 1. And negative 1 times negative 1 is positive 1. So I'm going to add positive 1 to both sides in order to complete the square. Because that's going to cause the left side here to factor into x minus 1 squared. And the right side becomes negative 2. Alright, this I can actually solve. So x minus 1 squared equals negative 2. Whoops. First step to this is going to be to square root both sides to get rid of the square. Don't forget plus or minus. Alright, so I get x minus 1 equals plus or minus square root 2i. Don't forget about the I. This is the square root of a negative number. So it is going to be I. I'm going to solve for x. So I'm going to add 1. Great. And I'm going to have my solutions. 1 plus or minus square root of 2i. This is a complex solution. This is a complex number. These represents two solutions, two complex numbers. One of them, x is equal to 1 plus the square root of 2i, and x is equal to 1 minus the square root of 2i. Complex numbers here, so our solutions are not real numbers. If you tried to graph this quadratic, 3x squared minus 6x plus 9, it would not cross through the x-axis because its solutions are complex, which are not on the x-axis. Alright, so those are my solutions for number 3. Let's look at number 4. So number 4 is 2x squared minus 12x plus 50 equals 0. 2x squared minus 12x plus 50 equals 0. Alright, so same thing here. I'm going to divide both sides by the a value to get rid of it. So I'm going to divide the left side by 2, divide the right side by 2. Alright, so remember, you can distribute the division just like you would distribute multiplication, because I'm technically just multiplying both sides by 1/2. So this would be x squared minus 6x plus 25 equals 0. Alright, this is just the division property of equality, which is the same thing as the multiplication property of equality. Alright, 25 needs to be, well, it doesn't need to be, but it would going to be more useful for it to be on the other side. So that's going to give me x squared minus 6x. On the other side is negative 25. And then I'm looking for the number that will complete the square on the left side, which will make a perfect square trinomial over here that I can then factor into a perfect square. So negative 6, half of negative 6 is negative 3. Negative 3 times negative 3 is positive 9. So I want to add positive 9 to both sides, because that will cause the left side to factor into x minus 3 squared. And the right side is negative 14. Yeah. No. Whoops. Negative 16. Negative 16. Alright, so what I want to solve here is x minus 3 squared equals negative 16. So, square root both sides. Don't forget plus or minus. It's going to leave me with x minus 3 equals plus or minus 4i. Alright, let's get that 3. So add 3. So x is equal to 3 plus or minus 4i. Once again, my solution is a complex number. There's two solutions. X is equal to 3 plus 4i. X is equal to 3 minus 4i. And these are my two solutions here to my quadratic 2x squared minus 12x plus 50 equals 0. These are the two solutions for x that would make this equation true. Not real numbers. These are complex numbers. Complex that would make these true. Let's take a look at a couple more. 5. 2x squared minus 5x plus 3 equals 0. So this is number 5. Alright, we got to get rid of that 2 because the a value has to be 1 to complete the square. So we'll divide the left side by 2 and the right side by 2. Remember, the division can get distributed. So I'm going to have x squared minus 5 over 2x plus 3 over 2 equals 0. Let's get that 3 over 2 onto the other side. And guys, do not work with decimals. Always work with fractions. Alright, this is not going to be pretty if you work with decimals. It's going to be way better if you work with fractions. Even though it's going to be a little bit more difficult, it's going to be better. So on the left side, I have x squared minus 5 over 2x. On the right side, I have negative 3 over 2. And now I need to complete the square. So, negative 5 over 2. Half of negative 5 over 2 is negative 5 over 4. And negative 5 over 4 squared is 5 squared is 25. 4 squared is 16. So to complete the square would require adding, sorry, I should have done that in a different color, 25 over 16. Alright, so that will cause the left side to factor into a perfect square. I'm back down over here. So the left side is x minus 5 over 4 squared, right? And then the right side, well, for the right side, we're going to have to add, well, we're going to have to do negative 3 halves plus 25 over 6, which means we need to common denominator, which is 16. So if I multiply the top and the bottom by 8, this is actually 24 over 16 plus 25 over 16, which negative 24 over 16 plus 25 over 16, just add the numerators. So I get 1 over 16. Alright, so that was actually 1 over 16. Negative 3 halves plus 25 over 16 is 1 over 16. Alright, so now I've got the perfect square on the left side, and I can solve this by square rooting both sides. Don't forget plus or minus. Alright, so I'm going to have x minus 5 over 4 equals plus or minus 1/4. Okay, because the square root of 1 is 1, and the square root of 16 is 4. Because you can just split the square root symbol to the numerator and the denominator. Alright, well, we're almost here solving this. We're going to add 5 over 4 to both sides. So our solution, we're going to have 2 of them. X is equal to 5 over 4 plus or minus 1 over 4. Alright, we can actually calculate these two solutions. Alright, we can calculate these because this is a real number. We have 5/4 plus 1/4, and our other solution is 5/4 minus 1/4. Okay, so one of our solutions is 6/4, which is 3 halves. So one of our solutions is 3 halves. Our other solution is 4/4 or 1. So my two solutions, 3 halves, 3 over 2, and 1. Alright. This one probably could have been factored. Since our factors were real numbers, or since our solutions were real numbers, this one could probably have been factored. Yep, pretty sure it could be factored. But completing the square also works. It works just fine. It takes a little bit longer. Well, depends. So our solutions, 3 halves and 1. You might see it as a set, 3 halves and 1. You might see it like this. Alright, number 6. X squared plus 8x plus 22 equals 0. Okay, this one's kind of easy. X squared plus 8x plus 22 equals 0. Well, the a value is 1, so no problem there. We can put the 22 on the other side, so we're going to have x squared plus 8x. On the other side, I got negative 22. Now I need to complete the square. So half of 8 is 4, and 4 squared is 16. So I'm going to add 16 to both sides. And that's going to cause the left side to factor perfect square x plus 4 squared. On the right side, I have negative 6. Okay, now I can solve. Square root both sides. Don't forget plus or minus. X plus 4. X plus 4 equals plus or minus square root 6i. Get rid of that negative there. Square root of negative 1 is I. Let's get this 4 out of the way. Minus 4, minus 4. So I'm looking at x is equal to negative 4, because the real number always comes first, plus or minus square root 6i, the complex number. It's two solutions. X equals negative 4 plus square root 6i, and x equals negative 4 minus square root 6i. So complex solutions for number 6. We have complex solutions, our two solutions. We may see this as a set. -4 plus square root 6i, -4 minus square root 6i. We may also see this as a set of solutions as well, so this is also possible. All right, there's the homework there, page 53, number 24, page 54, 23, 26, and 29.